Okay, so welcome to the third day of the Semantic MediaWiki conference. It is the Research and Education Day, which I especially like because Semantic MediaWiki was actually invented from a research group, and I'm very happy that Basil Ell is here because not only is he doing a great presentation with his work now from the University of Osnabrück, right? Is that right? Yeah.
Bielefeld.
Bielefeld, sorry. Yeah, Bielefeld. But what is important and what you must know, he was a student, I guess, in Rudi Studer's group when Danny Frandecic and Markus Kretsch invented Semantic MediaWiki. So he was there. So he has a very deep understanding and knowledge, I guess, of what Semantic MediaWiki is and what it can still do today. And I'm happy that he's here. And the floor is yours. Moritz, welcome. And Florian hopefully will join soon. He just dropped out, but he will be back soon, I guess. So the floor is yours, and thank you for being here.
Thank you.
Thanks a lot, Bernhard, for the very nice introduction. And hello, everyone, and welcome to our presentation on the integration of OTTR templates into Semantic MediaWiki. My name is Basil Ell, and what we are presenting today is the result of joint work between my Bielefeld colleagues Moritz Blum and Florian Schröder and myself. Okay, next slide, please. So you may not know yet what OTTR templates are and what they are for. So let me start with introducing to you the motivation for OTTR templates. So the developers, the main researchers behind OTTR templates are Martin Georg Schäveland, Leif Harald Carlsen, and Daniel Lupp. And what they state is that current data and RDF data engineering methods are too low level, and they compare this to programming in assembly language. Basically, that means if you create and manipulate RDF graphs at the level of RDF triples, then this is very limited. And this makes it difficult to interact with RDF data and to not introduce any errors into the data. Furthermore, RDF data as it is, even though there are human readable syntaxes for it, it's still difficult to be understood by domain experts. And that means it's difficult to engage with end users. And all the problems with dealing with RDF data at that low level means that it's difficult to maintain RDF graphs. So what we need are better abstractions that enforce and ensure consistency and uniformity. Next slide, please. So therefore, reasonable ontology templates, also called OTTR templates, were developed. It's a template mechanism for encoding ontology patterns. And not just for ontology, also just for data. I mean, data is, ontologies are data as well. So it's the same here. It can be viewed as a macro language for knowledge bases, and it allows to abstract over RDF and OWL. Thereby, it hides the complexity of the underlying modeling languages, which are RDF and OWL, and it provides friendly user interfaces. So we can then build and interact with ontologies via templates. And one important principle here is the do not repeat yourself principle. You model things in one position only. And if you want to change something, you only have to change it in one position and not everywhere. This allows you to model data uniformly. And also there are functionalities that allow you to ensure the completeness of input. Next slide, please. So let me start with a very simple example. This is apart from the well-known pizza ontology, or an extension of the well-known pizza ontology. You see here a couple of RDF triples, 9 RDF triples, where described, for example, in the first block of statements that Margherita is a class. It's a subclass of the class of pizzas, and it has an Italian label Margherita. And in all those 3 blocks, you find the same pattern that reoccurs. So if we highlight this now, in blue, we see what is different in each block, and in black, we see what is the same in each block. And so it's a modeling pattern that we use here, but now we want to extract the pattern. That's what we can do in the next step. Next slide, please. So here we can turn this into an RDF graph pattern. It's an RDF graph with the variables. So we have replaced Margherita, the URI, with the variable name here. Next slide. And now we can turn this into an OTTR template. So this is almost an OTTR template. What we see in the first line is the signature of the definition of the template. We give the template a name. We call it pizza template, and we declare that this template has two parameters, which are name and label. And these variables then occur in this block here. Next slide, please. So this is now a complete definition of an Otter template. Here internally within the definition block of the template, we specify that we make use of another ontology, another Otter template, which is Otter triple, which just creates an RDF triple where these variables occur again. So, and now we can see here how we instantiate this pattern. We can say in the last 3 lines, we call the pizza template and we just pass the values for the variables, which are Margherita and Margherita as an Italian label and so on. And thereby we uniformly model the data as an RDF whenever we instantiate the pizza template. Next slide, please. We can even go one step further where we say within the definition of the pizza template, we want to declare that we make use of the subclass of template, because later maybe we do not want to use the RDFS subclass of property, but something else. So according to the do not repeat yourself principle, we would factor out this part with the subclass of relation into another template. So whenever we want to change which property we use, we only need to change this one subclass of template. And so this is the final slide. So the instantiation looks the same on the right side, but now we can easily adapt the data and declare how this is actually turned into RDF data. So it allows us to abstract from how we actually model things. To the end users, we would just show the instantiations of the templates, so the last 3 lines. And the end users do not necessarily need to understand how the RDF data really looks like and how it is really modeled in RDF. Furthermore, it realizes the do not repeat yourself principle. Whenever you want to change something, ideally you just have to change it in one template. It encapsulates complexity. We can nest those templates. So within the definition of a template, we can make use of other templates that make use of other templates. So this can be deeply nested. Thereby, we encapsulate the complexity. And like in programming language, we can factor out things into like different modules. We can ensure the uniformity of modeling, because whenever we call the pizza templates, we can ensure that the data looks exactly that this modeling pattern is used. This is different from when you create RDF data directly. Furthermore, we separate design and content. So the content is what we input into the instantiations, like in the last 3 lines, and the design is the definition of the template. So this is separate. This can be separate files. Different user bases can work on the different aspects here. And it's a simple input format if you consider the last 3 lines. I mean, we have not shown you all the different language features of Otter. You will see a couple of features more, but it's still a relatively simple input format. And the whole thing about Otter template is that's a template language, and it makes use of substitution and macro expansion. Therefore, it is very similar to what Semantic MediaWiki does or what MediaWiki does. Therefore, we thought it's very natural to bring Otter templates into Semantic MediaWiki. And by that, I will now hand over to my colleague Moritz Blum.
Thank you, Basil. Now I'll give a short overview about how we use Otter in our project context. And then I use this to motivate the integration of Otter into Semantic MediaWiki. We are using Otter templates in our project called DiproMark. DiproMark is about the digitalization of a process chain for the production, characterization, and prototypical applications of magnetic caloric alloys. And in the context of this project, we are developing an ontology to semantically describe the experiments our domain experts do. This includes, for example, measurements and measurement data and production steps, for example, and so on. And we are in contact with the domain experts to develop the ontology together. And that turns out that we need somehow a translation between the ontology to the language domain experts can understand. It turned out that the Otter templates are really useful because they give a good structure that even domain experts can directly understand. And then we use this in interaction with them to first design these Otter templates, and then domain experts on their own can instantiate the templates. Our practical application has shown that this mechanism of using auto templates really helps a lot, because the domain experts can understand and maintain the data by instantiating templates or editing already existing template instantiations. They can actually propose their own ideas for extensions or changes of the ontology, because they understand the ontology, and furthermore, they understand the dependencies in the ontology and how the different parts relate to each other. And we already use in this project context Semantic MediaWiki for gathering and exploring information, and therefore, the idea come up to integrate Otter into Semantic MediaWiki, and that seems really harmonic to us to do this integration, because SMW already has this template mechanisms, these pattern mechanisms, which are really quite similar to Otter, and we had the idea to extend this. Then the instantiated Otter templates are creating sets of triples, and these are naturally living in Semantic MediaWiki. That's another thing that would be great that's great for the integration. And furthermore, we have the Semantic MediaWiki is organized into pages, and there it would be quite easy to have one page for each template and one page for each instantiation. There are much more features which are great about using Semantic MediaWiki for Otter. That's the first thing that's really good for collaboration, because Semantic MediaWiki is online accessible, and all project members can interact over the wiki. The wiki gives us namespaces and simplifies the administration. And on the following slides, I have a few more things. For example, as I explained, the Otter templates create triples, and if the triples are living into the wiki as sub-objects, we are able to query these through already implemented ask queries. Then furthermore, we have the collaboration and the discussion features of the Semantic MediaWiki. For example, the domain experts can start a discussion on a certain wiki page about a template or a template instantiation, and they can see the history of the page where, for example, as you can see here, the template is changed, or for example, if an instantiation is changed. And furthermore, it would be nice to use these forms in the wiki to instantiate Otter templates, but Florian will now show you all the Otter features and what we have implemented. Yes. Florian, do you want to share your screen?
You can do it, I guess, also. But yeah. So yeah, I will talk a little bit about the Otter features and how they are implemented in the extension. So first, the extension parses the Otter code and produces wiki code. So now we can create templates or white templates on pages in the template namespace. The name should be equal to the page name of the template. And now we can use these templates in other templates or instantiate them on normal pages. And last, we can then create automatically page forms that are more user-friendly for generating or instantiating these templates. Next slide. So we declare Otter code with these Otter tags, and we insert the Otter code inside these tags. We can see the example from the beginning. On the left, there is the template that we write on a template page. And on the right, we can see some instances or instantiations. Next slide. If we now look how the pages are rendered, there are different parts of it. We can turn them off and on for the whole wiki. But yeah, we can see the definition of the Otter code again, and then how we can create a form for this template, and also the produced wiki code if someone is interested in that. And then on the instantiation page, we can see also some debug information, for example, about the number of initialized triples or of the used templates. And also a table of that shows all generated Otter triples. This is done with an ask query right on that page. Next page. Next slide. We store the triples with sub-objects and also with additional data, so we can query it quite easily with this sub-object category Otter triples. And on the right, we can see the generated, so the table of the generated triples. And that's the same as from the beginning Basil showed us. So next slide. Now Otter has some more features, so I show some of them. So we also can declare default values. If we pass now none or Otter none to the to an instance or to a template, then we can see on the bottom right that it uses the default value instead. Next slide. Also, we can handle none input with optional arguments, because by default optional none is not a valid input. So if we declare it as an optional argument, it will produce the inner templates, else it will not produce any templates. Next slide. Also you can use blank nodes to connect different triples inside a template. This is a feature not presented by Otter, but you can use it with Otter, and the extension produces blank nodes with the execution path, because the Semantic MediaWiki has no feature for blank nodes right now. So if you change the input of the instantiation, for example, with correct a typo, it does not change. So the referred blank node does not change because the execution path is still the same. Next slide. So also we can now use blank nodes or declare arguments as not, so that not blank nodes are not a valid input. For example, if we now say that the name has to be a non-blank argument, we can do this with the exclamation mark. And if we now insert on the right side an anonymous blank node, it produces an error and will generate no triples. Next slide. Also, a simple type checking behavior or feature is done in the extension, so we can check for the literal type of the input. So for example, we can say that the first has to be a URI or a normal page in the wiki. So we declare it as OTTR and the second as a string. And if we now switch the arguments, it produces also an error. So currently it's only uses or checks for literal type checking and no complex inferencing, for example, for the class type or subclass of relationship, because there is no corresponding query feature in the Semantic MediaWiki, so we cannot currently implement that very easy. So only the type checking of the literal or an URI is done. Yeah, so next slide. So then there are lists in Otter. So for example, if you want to pass similar data with the same relationship to a template, for example, in the with the pizza template, you maybe want to pass toppings to the template. So you could do this via a list. And then if you want to use the elements of the list, you can have use the expand operator. If you have multiple lists, there are different behaviors of expand operators. Next slide, we can see the different behaviors of it. So zip_min and zip_max, connects the elements of the list pairwise. Min until the end of the smaller list, and with max until the greater list, and fills the missing elements with none. And cross produces somehow a cross product between them. An example for this would be for person URIs. You want to connect them with, for example, the person reference and the employee reference, and after the execution of this template, all of the persons are connected with the person and the employee URI. So next slide. So now to the feature that is related to the MediaWiki and not to the Otter itself. Next slide. We can create automated forms, and on the template page we can see that there is a create form button. Then you can click on it and it opens up a new page in the wiki with the same name, but in the form namespace. And it also inserts the valid input, valid text that creates a form corresponding to the template that has the information that is stored in the signature, for example, default values and the type checking. And next slide, we can see an example. So if we click on save and we want to create a page or edit a page with this form, we can see that you can create instances, and you see that there is the information that we pass to the template is also visible on this form. So the default value is visible, and also the type that it needs is displayed on the right. That's all. That's the main features of the extension. That are the main features. All in all, we presented the extension that brings the benefits from Otter to SMV. With a better abstraction, you don't repeat yourself, as Basil explained it, and you can uniformly model your data and correlations between them. And with the templates, you separate your design and the content in the templates and the instances, and ensure the completeness of the input. All in all, you use you can use optional and default parameters, and the literal type restrictions and other features can help to display the user experience or restricted types that you want to use in different templates. And the automated forms, improve the user experience a lot and bring, shift the experience from normal text input to different input fields. And all in all, you can see the links. They are also in the chat. And thank you for your attention. And maybe you have some questions you want. Feel free.
Thank you very much. That was very impressive. That's actually the best case. Somebody keeping the time, so we have more time for questions, and presenting something that is open sourced already and is used already. So that's very nice. There is a first question. Yaron says, Otter seems extremely useful. A few questions. Is the first tool for defining class structures within RDF? If so, why did it take so long for someone to create something like this? Is it because class structures are viewed as contrary to the open nature of the semantic web?
Okay, maybe I can answer to this. Thank you for your question, Yaron. When I first saw Otter, I thought, well, this feels so natural. Why didn't someone come up with this before? So it could be that someone did, but I'm not aware of this. And also the Otter developers are not aware of this. But still, it feels like a very natural thing to think in terms of templates, to model in terms of templates. And especially this is relevant if you come from structured data that you have already in some form and want to step-by-step transform this into RDF data. So regarding the other questions by Yaron, whether this is because of that is somehow contrary to the openness nature of the semantic web, I don't know. So I don't know why this happened, that it did not exist earlier.
Okay. Currently don't see other questions in the chat. I would have a question. Did I understand it correctly that you are not using the properties in Semantic MediaWiki, or are you using the properties?
Because you want to, you were talking about the that always the subject is always the page on that you write the or maybe I'm wrong. So currently not, no. So we only use the sub-object to store the most cleanest way of triples. And
but even in a sub-object as the predicate, you would have a Semantic MediaWiki property in the property namespace usually. Do you do that? Or because I've seen in your slides the predicate table and it said predicate RDF type.
Yes.
And I was wondering, why is the predicate not called, I don't know, has ingredient or whatever it is called, and beneath that could be the RDF type, which is something that Semantic MediaWiki can do if you use Semantic MediaWiki properties for that. So I was wondering.
Yes. So in the first way, it was the idea to make to mimic mostly the same behavior as in the Otter language, and then it was more a design decision to say the user can specify any predicate. So in the predicate position. So currently you can also insert string as predicate. There is no, so the Otter triple template is also only a template that you can change. And if you want to do completely, maybe quadruple or something, you could do this because it's not that defined, because it's only, the Otter triple is only a base template, but you can generate base templates by yourself, and it's not defined special on these Otter triplet templates. So yeah.
But maybe one thing to clarify, I mean, the Otter parser parses Otter syntax and generates wiki code that will then make use of wiki templates, MediaWiki templates, and create sub-objects. So you can make use of predicates in the way that MediaWiki does, or Semantic MediaWiki does. So you can make use of existing predicates when you create triples via Otter templates, and you can query them via ask queries in a natural way. So this is possible.
Okay, thank you. There's another question in the chat. How can I use data created through Otter inside MediaWiki or outside? Do you have a use case once created an example ontology?
Okay, so it's easy to distinguish the Otter triples from the triples created via Otter templates from other triples from other RDF data that you have in your MediaWiki, because you can query for all the sub-objects where you explicitly know that they were created via Otter templates. Of course, you can also change the base templates that we have. I mean, one base template says take subject, take predicate, take object, and put them into a sub-object. You can also rewrite this template to handle this data differently so that it's more natively within MediaWiki or Semantic MediaWiki. So collecting all this data is easy. Exporting all this data to RDF is also easy. I mean, it's automatically there. It's within sub-objects.
Okay. Yeah, thank you very much. We are running out of time. I hope you will be around today a little bit longer, so maybe we can discuss at the end of the conference, or people can write you in the chat. Okay, thank you very much. Let's move on. Is Laura D. Rocky already there? Bye bye. See you.